Hey, this is Mr. Ward, and this is the Geometry Do Now 30.2 video key. And here we go. We have, we need to expand this a little bit so we can see what we're talking about. So I have edited this to make it really clear. In the last exit ticket in class, we worked out that if we took a right triangle, laid it on its hypotenuse, and dropped an altitude from its hypotenuse, that this angle and this angle were congruent, and this angle and this angle were congruent. And of course, the right angles are all congruent with each other. So what we need to do is prove that triangle ADC, this is ADC, is similar to triangle ACB, which is similar to triangle CDB. The order of those letters actually matters because it relates to how you would prove this. So we are trying to prove Theorem 60, Part A, which is that two triangles formed are, these two triangles formed are similar to each other, to the given right triangle, the big one. So these two smaller ones are similar to this big one and also to each other. So that's what we're trying to prove. So here's how we would approach this. What you want to prove is, so if you have all the angles of a triangle, all the corresponding angles of a triangle are congruent, then those triangles are congruent. So all we have to do is take advantage of the angles. Now, the reason for these angles being congruent is important. So we can start off with this angle is going to be different from this one. This is going to be, well, maybe. So this is 90 degrees, but this angle is going to be complementary to this one. These two angles add up to 90 degrees. Now, but this angle here is part of this right triangle. And so because this is 90 degrees, this angle is complementary to this one. And if this angle is complementary to this one, and this angle is complementary to the same angle, then those two angles which are complementary to this angle are congruent. Finally, this angle here is also going to be complementary to this one or this one, here, because it's what completes the 90-degree angle. Here, because it's what completes 90 degrees total for what's left. Okay, so we have three similar triangles. We're trying to prove that they are. So let's start with the big one. So triangle ABC. So here's what we can say. Angle A is congruent to angle BCB. Okay. We can also say that angle B is congruent to angle angle B is congruent to angle DCA. And then finally, we can say that the following angles are congruent. So angle ACB is congruent to angle ADC, which is congruent to angle BDC. Okay, and all of those are congruent. These are because they're 90. Okay, and right angles are congruent to each other. A and BCD, because they are complementary to the same angle. And these two for the same reason, because B and DCA to the same angle. Okay, now we have what we need to prove that the triangles are congruent. Okay, so triangles ADC, triangle ADC is similar to triangle ACB is similar to triangle CDB, by angle, angle, angle. You can actually do it with just two angles because the no choice theorem forces the third angle to be congruent. Okay, so what's happened here? So the angle that has the vertex at A, this is A here, okay, notice it's congruent to the angle that's vertex A here, and that's also congruent to angle DCB. So this angle is congruent. So this angle is actually shared by two right triangles. This smaller one and the overall big one. It's sort of like flipped on it, pivoted around. So this triangle is congruent to this triangle. And what you want to do when you're naming them is you want to name them along the pattern of the congruency. So triangle ADC goes from this green marking to right angle to the purple one. Triangle ACB goes from the green to the right angle to the purple one. And then CDB goes from the green one to the right angle to the purple one. So that's the pattern you want to follow. You want to follow the angles. Okay. So all of them have congruent, corresponding angles. Now this only proves similarity. It does not prove congruence. Now let's take a look at some implications of that. So since triangle ACB is congruent to triangle CDB, how are sides A and C and A and Y related? Okay, so we're looking at triangle ACB, the big one, and we're looking at this little partial triangle down here, okay? We want to look at AY and A and C, okay? So A to C to A. So C is the hypotenuse of the big triangle, and A is the small leg of the big triangle. So A to C, we'll make a ratio there. So we can say A to C, and then let's take a look at A and Y. A is the hypotenuse of this small similar triangle, and Y is the small leg. So we can also say that Y to A, okay, and that those are a proportion. Y to A is the same as A to C. Y to A is the same as A to C. And if that's true, when we get the cross products, then our extremes are going to be Y and C, and our means are going to be A and A. So A times A, so that means that A times A is going to equal Y times C. And that means that we can just say A squared. A squared equals YC. And that is a really important proportion for this triangle. We're going to take a look now at B and C and B and X. So let's look at B and C. So B is the long leg and C is the hypotenuse of the big triangle. And B and X, B is the hypotenuse of this triangle, and X is the longer leg. So we've got B as a longer leg and X as a longer leg. So they're going to hold the same position in this proportion. So what we can say is hypotenuse C is to leg B as hypotenuse B is to leg X. So let's set that up. So C is to B as B is to X. And that becomes, when we do the cross products, b times b. So we can just say b squared is going to equal cx. And that also means that b is going to equal the square root of cx. And then we can go back to the previous one up here and take that implication as well. We get this, we can find out that a is going to equal the square root of yc, or cy if you prefer. Okay? And so that actually is going to give us some powerful problem solving tools for these triangles. Okay, now let's go one more and take a look at it. So this last one, we want to make a case for this proportion statement in B below. So the proportion statement here says x is to h as h is to y. Well, x is the long leg, h is the short leg for this left triangle, and h is now the long leg and y is the short leg for this right side right triangle. And so they in fact will have that proportion. Okay, so because triangle ABC is similar to triangle CDB, okay, and let's think about what X is. X is AD, so AD, and H is CD, okay? H is also DC, so AD to DC, AD to DC is CD to DB. Okay, so you can actually follow those patterns in the name. Okay, because they are similar, this proportion let's say X and H have the same ratio as H and Y. Okay, so we can work out that proportion. Of course, H times H will be H squared, and X times Y will be XY. And then you could actually figure out what H is. H will be the square root of the product of X and Y. All right, I hope that was helpful.